Welcome back to Bee Spice. In this session, we'll discuss about a new topic, methods of protection. Methods of protection in the sense, we'll talk about flame proof, we'll talk about explosion proof, their features, their application, the benefits, and what else? Yeah, and the testing methods. All those we will see in detail. Okay, so let's move on with the details. Flame proof. As we all know, we call this flame proof as EXD, right? Yeah. So the standard related to this flame proof, the standard related to this EN IEC 6070079 part 1. Okay. So here in flame proof, actually, the enclosure of flame proof equipment is designed to withstand internal explosion. Basically, the flame proof equipment is designed to withstand an internal explosion. So that is the constructional feature. So the enclosure joints permits products of combustion. So just listen carefully, friend. The enclosure joints actually permits products of combustion and the resulting expansion of gases to be relieved through the joints and not to permit that explosion to transmit through the external atmosphere. You got it? So basically the enclosure joint permit product of combustion. Okay. So the resulting expansion of gas, gas expands, right? So that to be relieved through these joints actually. Okay. And but not to permit that explosion to transmit to a external atmosphere. So that is the, design feature. Okay. So EXD is a type of protection in which the parts that can ignite an explosive gas, air mixture, are placed in an enclosure, okay, which can withstand the pressure developed during an internal explosion and which prevents the transmission of explosion to the surrounding external atmosphere. I hope this is clear, right? Yes. So it's basically a type of protection in which the parts that can ignite an explosive gas air mixture are placed in an enclosure which can withstand the pressure developed during internal explosion and which prevents the transmission of explosion to the surrounding external atmosphere. So this is a basic intro about the flame proof, right? Okay. So now I want to talk about something on this actually. Friends, flame-proof enclosure are constructed to withstand an internal gas explosion, right? Without damage to the enclosure and to cool the hot gases produced by the explosion as they exit I think this is a typo error, as they exit the enclosure along the flame path, okay? So consider this is your enclosure, right? So basically, this is designed and constructed in such a way that to withstand the internal explosion. So without damaging the enclosure. And the whatever the gases, produce here, it will be cooled actually when they exit this enclosure along the flame path. Okay. So that is the design feature. Okay. Now, gases in critical groups like 2A, 2C. Now this is 2C. Critical groups is 2C, right? So required longer flame path, meaning it required longer flame path to cool the gas and sometimes thicker walls, to contain the increased pressure of an internal explosion. This is the point. Critical gas group, we need to have a longer flame path, okay, to cool the gas and thicker valves to contain the explosion. Okay, friends, you got it right? Yes. Now, I'm actually going to, talk about the comparison here, flame proof versus explosion proof, basically. So these are the consideration, field drilling. Let's talk about field drilling. In flame proof, it is not allowed. And because it must be drilled by the manufacturer. Okay, we are not supposed to do any drilling here, flame proof. But in explosion proof, it is acceptable. Okay, right. Pressure testing, the flame proof is tested for 1.5 times the maximum, 1.5 times maximum. Then this guy for explosion proof is 4 times maximum. Okay. And construction, this is very lighter and this is heavier actually. And when you talk about the joints, it's threaded, flag, and spigot. This is one type of construction actually. And when we talk about the explosion proof, this is also threaded, flat, and one is the labyrinth. It's a serrated structure. Then, when we talk about the entries, factory drill directly onto the enclosure, as I said here, factory drill or field drill into a XEE enclosure. It's like an indirect entry actually. It's a field drill into a EXE enclosure. Okay, the separate enclosure. So this explosion proof field or factory drill directly into the enclosure. So these are some of the differences actually. Now we'll talk about more on the flame proof construction. See the meaning here. See, a potentially explosive mixture can be present inside the flame proof enclosure. Why? Due to the heating and cooling cycle of electrical equipment use, right? You got it, friends? Potentially explosive mixture can be present inside the box, the flame-proof enclosure, due to the heating and cooling cycle of electrical equipment use, right? Yeah. So this is how actually, okay? Here, for example, you see this is your enclosure and an air-gas mixture can be sucked in, and expelled as the temperature changes, right? Sucked in and expelled as the temperature changes. Then here, if the air gas mixture inside the enclosure is between lower flammable units and upper flammable units, between lower flammable units and upper flammable units, and a spark, I think this is again a typo error, a spark ignites the mixture, an explosion will occur. This is just understand the flame proof concept. Here, air gas mixture can be sucked in and expelled as the temperature changes. Okay. And this one, I'm talking about the, what do you call the limits, lower flammable limits and upper flammable limits. If the air mixture is inside this between lower and upper flammable limits, spark actually ignites a mixture and explosion will occur. Of course, that explosion, it has to take care. That is a point. That is why we go for a flame proof. But I'm just trying to explain here. What is the concept here? So again, the hot compressed gases are forced out because whatever is here, the hot gases are forced out through the flame path. I told you, right, the flame path, right? So, but must not ignite any surrounding potentially explosive atmosphere. So that is the concept here, because it gets cooled through the gas flow path. Okay, got it, friends? Yeah, yes, flame path, yes. So flame path cools the hot compressed gases. That's what I said. The flame path actually cools the hot compressed gas as they are expelled, preventing any explosion of external atmosphere. So this is the typical construction of flame proof. So I hope you got some insights on this flame proof aspects, right? EXD. Okay. Few more actually. There are also some more constructional design aspects actually. All internally components, or what is that? One moment, friends. I need to recheck this actually. All internal, sorry, again a typo error, apologize for this. All internal components in the EXD enclosure must have a common clearance of at least 12 mm from the internal enclosure wall. So that is the point. You see here, friends. So this is your enclosure, right? So it should have at least 12 mm, 12 mm clearance from the internal enclosure wall. Okay. So this is what this is inside. This is, for example, this is your components inside. Just assume it must have a 12 mm clearance from the internal enclosure wall. Okay. So there are different grouping and different distance. If it is gas group 2A 10 mm, 2B 30 mm, 2C 40 mm. Okay. So this is how it classifies actually. Okay. So in addition, obstructions adjacent to the external flame path can cause pressure piling, which results in an abnormally high explosion pressure. So what I'm saying here, addition to this, if there is any obstruction to the external flame path, when it comes out, if there is any obstruction actually, then that will cause a pressure piling. So what is pressure piling? I'll explain in the next slide. So it is assumed that, oh, maybe I need to talk about the pressure piling. Yes. Yeah, I think I have put it in the next slide. Okay. So it is assumed that the flammable gas in the surrounding atmosphere here can enter the flame-proof enclosure by thermal cycling or breathing. This is the normal way of, phenomenon actually. Okay. So a flame-proof enclosure is built to withstand the pressure developed during the internal explosion following ignition without damaging the enclosure. So that is what this flame-proof is all about. So in addition to the outstanding internal explosion, the flame path width and gap in the flame-proof enclosure must cool the hot flaming gas, right? So as they pass through the flame path to prevent the ignition of any surrounding explosive atmosphere. I am repeating this just to re-emphasize this. In addition to withstanding the internal explosion inside that box, like flame-proof, the flame path is there, right? The width and gap, right? So that also must cool the hot flaming gas as they pass through the flame path to prevent the ignition of any surrounding atmosphere. So the pressure inside the flame-proof enclosure during internal exposure can even rise up to 10 bar. Just imagine, friends, 10 bar. Okay. So there is also a possibility of pressure piling. This is what I mentioned earlier. And detonation due to the secondary ignition of compressed gas inside an enclosure that can result in pressure of 30 bar. If there is a possible of secondary ignition, then it will go up to 30 bar, 10 bar to 30 bar. So what is this pressure piling? Here, pressure piling is nothing but an increase in explosion pressure above the normal expected pressure caused by the ignition of pre-compressed gas. And this can result from modifications such as, some internal subdivision of flame-proof enclosure or any external obstruction. If there is any internal subdivision or any external obstruction to the flame path, this actually pressure piling can happen. So once the pressure piling happens, then the 10 bar can rise up to 30 bar. So that is that point. Okay, friends, you got it? Okay. So I also want to talk about something more on this actually. Okay. We are talking about the 30 bar, 10 bar, right? So I want to say something on this actually. The static pressure test requirements for flame-proof enclosure, right? The static pressure test requirements for flame-proof enclosure are 10 bar for 2A, 2B gas and 15 bar for 2C gases. Just remember that. 10 bar for 2A and 2B and 15 bar for what do you call it? 2C. Okay, just for your info. Additionally, friends, when we design this flame-proof enclosure, here this threaded or spigot joints are used in 2C application because of the, okay, maybe I'll just start from here. Flat joint. If you talk about flat joint, the bolted joint, right? So that can be used only with 2A and 2B gas group. Just remember that, bolted joint. Thread or spigot joint or can be used in 2C application because the close tolerance and length of the flame path formed by the thread. That is why it's very critical, right? That is why the 2C actually. Okay. Then when we talk, and another point actually on the threading, the minimum number of thread engagement shall not be less than 5. The minimum number of thread engagement. Okay. And the depth of the thread engagement is up to 100 cubic cm is 5 mm and above 100 cubic cm not less than 8 mm. These are just additional information for you. And now we'll go into the testing method. There are many methods actually. Thermal test, thermal endurance, reference pressure and overpressure. First, we'll talk about the thermal test. See, what is this thermal test? Usually, a thermal test is the first test to be conducted to determine the maximum temperature of the components and parts under maximum service condition. For example, we have to use this manufacturing rating for the device related to the maximum ambient temperature in service. You got it, friends? What I'm saying is, usually thermal test is the first test to be conducted. What for? To determine the maximum temperature of component and parts under maximum service condition. Okay. So service condition in the sense manufacturer rating for the device and ambient temperature, right? Okay. An additional test at 0.9 to 1.1 times rated voltage may also be conducted at this time to determine the maximum surface temperature. Okay. So in addition to this thermal test, actually, additional test of 0.9 to 1.1 times the rated voltage may also be conducted to determine the maximum surface temperature. Again, this is related to the maximum ambient temperature in service. So this is, just remember this as a thermal test, okay? Then another is thermal endurance actually. What is this thermal endurance? See, basically here, non-metallic enclosure and cemented joints contributing to the flame-proof properties of the enclosure undergo thermal endurance, meaning high humidity and high temperature. So that is what call it as a thermal endurance. This is for the non-metallic part. And after that, we'll follow by the impact testing, also the impact testing, right? Okay, forget about this. But now the point is, we need to do this thermal endurance, which is a high humidity and high temperature. That is for the non-metallic parts. Okay, right. Then what is the reference pressure? Reference pressure. A series of tests are conducted to determine the maximum internal explosion pressure, right? That is what the main aspect, right? So we need to determine the maximum internal explosion pressure. So the test involved filling the enclosure with an explosive mixture of gas and igniting it. You got it? So the test involved filling the enclosure with an explosive mixture of gas and then igniting it. So special transducers fitted to the enclosure measure the resulting pressure. The internal arrangement of the equipment may be configured in various options as per the manufacturer. Okay. So that is the point, friends. So reference pressure test. Okay. What else? Yeah, depending on the arrangement of internal part, some configuration may give rise to a higher internal explosion pressure also. So that differs actually. Okay. Because, we talked about the pressure piling also, right? Yes. So this is because the complexity of the internal shape may slow the speed at which the internal explosion occurs. When the explosion is slower, the rise in internal pressure compresses the unburned mixture before it is ignited. This is called the pressure piling, which I talked earlier, right? So the point is, depending on the arrangement of internal part, some configuration may give rise to a higher internal explosion. Okay. So this is about the pressure. So this test involves filling the enclosure with an explosive mixture of gas. Right. Then overpressure. What is overpressure? Basically, a hydrostatic overpressure test is conducted. What for? To verify the mechanical strength of the enclosure. So leakage of the test fluid through the flame-proof joint is permitted. So flame transmission following the overpressure test, the test sample is also subjected to series of flame transmission tests using the same explosive mixture of gas. Okay. So what we will do here, the sample is placed in an explosive atmosphere. When the internal explosive mixture is ignited, it is not permitted for this to transmit through the flame-proof joint to the outer external atmosphere. So for equipment that has an ambient temperature higher than or lower than minus 20 to 40 degree, the reference pressure, overpressure and flame pressure test may be conducted at extremes of high and low, high ambient specified by the manufacturer. To sum up, friends, I think maybe I'm giving too much of information. See, to sum up, I just give a precise notes. Okay, testing method. One is the thermal test, friends. Okay, so this is the first test to be conducted to determine the maximum temperature of the components. Okay, right. Then thermal endurance. This is for checking the high humidity and high temperature. Then the reference pressure. This is for, by filling the enclosure with an explosive mixture of gas and ignite it and see whether it withstands actually with the help of typical, various transducers. Then overpressure. Basically, this hydrostatic overpressure test is conducted to verify the strength of the enclosure. So that's it, friends. Okay. These are the tests just for your awareness. Thanks. I hope this video was useful to you as far as to learn this explosion proof and flame proof concept. If you like this video, you can show your support by pressing the thumbs up button. If possible, become a member. Okay. Thank you for watching. See you in the next session. Bye.